In Unit 2, we talk about the nature of matter first, just to review the atom and all of the different parts. First, we'll start with matter. So matter is anything that occupies space and has mass. We have solids, liquids, and gases. So solids are close together and have a fixed shape. Liquids are not rigid. They have a fixed volume, but not a fixed shape. And then gases aren't rigid at all. They don't have any fixed shapes. So that means that you can compress them versus liquids that you can't really compress them so well. And then solids cannot be compressed. Whenever we talk about properties of matter, we look at physical properties, so things that can be observed without changing the matter itself. Freezing point, color, melting point, density, the state of matter, those are all physical properties. Chemical properties will be observed only when matter goes through a chemical change. So when you burn it, you see the flammability. You look at the toxicity. Whenever you put it on some metal, you see how corrosive it is. So chemical properties you observe only whenever there's actually a change that takes place. Physical changes are changes that happen where maybe it changes the appearance, but the overall composition stays the same. The molecules themselves maintain their original properties and are still bonded with the same atoms. On the other hand, chemical changes result in a change in the molecular structure. So things like bubbling, changing color can sometimes be indicators, not always, but sometimes. Whenever things are burning, if you form a precipitate, which is a solid, whenever there's an exchange of heat, those are some examples of chemical changes. Two types of reactions that we talk about in science. We have exothermic reactions, which are reactions that release heat as the reaction occurs, and then endothermic, which use heat, or really we'd feel them getting colder, and the heat's required to make the reaction happen. Exothermic reactions will happen spontaneously compared to endothermic reactions. So what is matter made of? Matter is made of atoms, which are the smallest unit of matter, and then elements, which are one type of atom. Elements are what we see on the periodic table. So elements would be oxygen, and the atoms would be oxygen atoms. So atoms are just one single thing. Elements would just be many atoms, all of the same type. So parts of an atom. So we have our nucleus, which is the central portion of the atom. That includes our proton, which is positive. It has a mass of 1 atomic mass unit. And then we have a neutron that is neutrally charged and has a mass of 1 atomic mass unit as well. So all of the mass in the atom is located in the nucleus compared to the outer orbitals, which contain the electrons. They are negatively charged, but they don't have an important amount of mass. Electrons are going to be responsible for bonding. They're going to be responsible for the reactivity of the atom itself. So here's a little table just reminding you of the key points about protons, neutrons, and electrons. You should know their charge, you should know their mass, and then you should know the location of where they're found in the atom. So all of these are considered to be subatomic particles, and you should be familiar with each of these. Whenever we look at elements on the periodic table can tell us a bunch of stuff. First, as you see in the center there, we have carbon. That's our symbol. So C is our symbol for carbon. Some periodic tables include the name, others do not. The atomic number is at the top there. That is going to be a whole number, and it represents the number of protons that are in the nucleus of the atom. The atomic number is unique to every element and every atom and is an identifying feature of it. So carbon is 6, nitrogen is 7, oxygen is 8. So every element has its own atomic number. The atomic mass, which is on the bottom, will be the average mass of all of the isotopes of a certain element. So isotopes are going to be a variation of the atom. They are going to be a variation where the number of neutrons is different. So that means that the mass changes, but the atomic number or the number of protons stays the same. Another way that we can write our elements are using what we would call a nuclide symbol. So in the center here, so this example up at the top, so we have our chemical symbol that would be here. We put our mass number in the upper left-hand corner, and that's going to be the number of nucleons. That's not really a word we use very often, but that's really the number of protons and neutrons that are in the nucleus. And then in the bottom left-hand corner, the Z, that's our atomic number. That's unique to every element. Really, we hardly need to include that because if we have the element symbol, the atomic number is really implied because each element has its own atomic number. Here's an example with lithium. So there's our symbol, we have our mass number, and we have our atomic number. The atomic number is number of protons. So we would then be able to figure out that, 7 minus 3, there's 4 neutrons in this example. So important definitions, we need to know atomic number, which is the number of protons. That's what we see on the periodic table, and that identifies the atom. We need to know the mass number, that's the mass of the element, which is protons plus neutrons. And then the atomic mass is less important in this class, but it's going to be the average mass of all of the isotopes of the atom. So, important things to remember, subatomic particles, protons, neutrons, and electrons, and understand what each of those contributes to.